All right, ladies and gentlemen, welcome back. This is question 7. We are almost done with the AQA 2018 Chemistry Higher Tier, paper 1. So, question 7. A scientist does 2 tests on 4 white solids. The solids are labeled A, B, C, and D. In the test 1, adds a sample of the solid to distilled water and stirs it. Test 2 measures the pH of the solution after test 1. So table 2 shows the results on table 2. Table 2 shows the results, and then we have table 2. So let's see what it says here. Solid A, appearance after stirring it. So you have colorless solution and there is no solid and the pH is 14. So they have the distilled water, they put the solid A, they mixed it up, they stir it up, the solid disappeared, right, because there is a colorless solution and there was no solids hanging around, so everything got dissolved and the pH is 14. Then we have solid B, and this one here, the colorless solution also happened and there is no solid, which means that solid B actually fully dissolved just like solid A, but this one has a pH of 3. Okay, then we have solid C. It was put into the water. You ended up with a colorless solution, but some solid did remain. So not everything got dissolved. Some solid remained, and the pH is 9. Then we have solid D. It was put into the water. A colorless liquid was formed, and then solid remained. Okay, so we also have some solid in that one there. And then that one has a pH of 7. Colorless liquid and solid remains. Now this is a bit interesting because this one says solution, but this one says colorless liquid and then solid remains. Okay, what this tells me is that because this one says solution, that means that solid A dissolved, solid B dissolved, solid C also dissolved, but not fully. Some of it remained, and solid D didn't dissolve because it didn't make a solution. Okay, and the solid remains with a pH of 7. So let's find out what's next. So the 4 solids are magnesium oxide, phosphorus oxide, silicon dioxide, and sodium oxide. The table shows the solubility of these 4 solids in water. Magnesium oxide has a solubility of 0.01, phosphorus oxide 52, silicon dioxide 0, and then sodium oxide is 109. Okay, that's how many grams of that substance you can dissolve in 100 centimeter cubes of water. Question 7.1. It says, identify solids A, B, and C and explain your answer. Right, so let's get this party started. First of all, I'm going to start with the solubility one. Okay, now we know that silicon dioxide has a 0% of solubility, and we also know that solid D did not dissolve because it didn't make a solution, it is just a liquid. So it's very likely that that is silicon dioxide. However, we also have a pH of 7, and from what we know, the solids were being mixed with distilled water, and water has a pH of 7. So putting 2 and 2 together, it leads me to believe, and I am able to explain my decision by saying that solid D is silicon dioxide. So let's write that one down first. There we go. So that is my reasoning, okay? Solid D must be silicon dioxide. It has a solubility of 0 grams per centimeter cube. And in table 2, solid D did not form a solution. And the pH was 7 for the distilled water, okay? I think that that is definitely the silicon dioxide, solid D. Now, what else do I have? What other information do I have? Okay, so we got sodium oxide, phosphorus, and we also have magnesium. Okay, now what can I figure out from here? Okay, now I know that this here is a metal, okay? And I also, sorry, there we go. So I know that this one is done. We have identified this one already, so that's cool. Magnesium is a metal, and I know that sodium is a metal as well. So I think I'm going to, obviously this one is a non-metal. Now, the first rule is that non-metal oxides, as a rule of thumb, okay, non-metal oxides usually, when dissolved in water, make acids, okay? This one will be an acid, okay? Now, let's keep that in mind. Which one of the three pHs is giving me an acid? Well, this one is neutral, okay? And the only one that is below 7 is this one here. And that one should be an acid, and that is solid B. So by that information, I can tell that phosphorus oxide, which dissolved in the water and there was no solid left behind, there was a pH of 3, must be phosphorus oxide, because that is the only non-metal that dissolves in water that is in there, okay? So let's write that down. All right, so there we have it. We have identified our second solid. Now we only have solid A and solid C. Now one of them is giving us a pH of 14 and the other one is giving us a pH of 9. And this is telling us that it forms a colorless solution, some solid remains, the other one forms a colorless solution and no solid remains, and that's the one with the higher pH. Now, how can we decide which one is which? Okay, so when we look at here, magnesium oxide has a solubility of only 0.01 grams, whilst sodium oxide has a solubility of 109. Okay, I think this will be a key factor to help us decide which one is which. Now, according to this, sodium oxide has the highest solubility and magnesium oxide is the lowest solubility from what we got from those two metals. So that implies to me that over here, a colorless solution was formed and no solid was left behind. And then you got a colorless solution was formed with some solid remaining. Now, there is no way that in here you will have sodium oxide, because sodium oxide has a very high solubility, which means that all of it would have dissolved and nothing would have been left. And I think most likely that the magnesium oxide is going to be the solid C, because the solubility is very poor, and we can see here that some of it got dissolved but some solid remains, and that may be explained because the solubility of magnesium oxide is very, very small compared to the sodium oxide. Okay, so by that we can tell that solid A has to be sodium oxide. All right, so there we have it. That is our 6 marks done. Solid D must be silicon dioxide as it has a solubility of 0 grams per 100 centimeter cubes. And in table 2, solid D did not form a solution and the pH 7 is from the distilled water. Solid B must be phosphorus oxide because non-metal oxides usually form acids when dissolved in water. And in table 2, solid B was the only one with a pH below 7. Solid A is sodium oxide, as it has a much higher solubility than solid D, than solid C. And in the table 3, we can also see that magnesium oxide has a solubility of 0.101 grams per 100 centimeter cubes, whilst the solubility of sodium oxide is 109 grams per 100 centimeter cubes, which makes solid C less likely to be sodium oxide, as some solid dissolved but some solid still remained. Right, so there you have it, guys. That is question 7.1 for you guys. So let's keep it moving and let's go to question 7.2. Now, it says here, 10 centimeter cube of solution B is added to a beaker. Distilled water is added to the beaker until the final volume is 1,000 centimeter cubes. The pH of the solution is measured before and after distilled water is added. Table 4 shows the result. So when the volume was 10 centimeter cubes, the pH was 3. Now that the volume, the solution is 100 centimeter cubes, when the distilled water was added, what is the new pH? And this is what is being asked of you, okay? Now, what we gotta know is that every time the concentration goes up or down by a factor of 10, the pH will go up by a factor of 1. So if I can explain this to you, so we got 10 centimeter cubes, okay, and then the pH was 3. If I times that by 10 and I do times 10 times 10, that's gonna give me 100. So if I had 100 centimeter cubes, because it's gone up by a factor of 10, the pH will be 4. Now, if I multiply that times 10, we're gonna have 1,000 centimeter cubes, which means that the pH has also gone up by a factor of 1 again. Okay, so once you have 1,000 centimeter cubes and 1,000 centimeter cubes, then the pH that you'll be looking at is 5. So the value of X in this question is going to be 5. Remember, every time the value increases by a factor of 10, it will increase the pH by 1. If it decreases by a factor of 10, it will decrease the pH by 1 as well, okay? So there you have it. That is question 7.2. So click on the next video so we can have a look at question 8 to finalize this paper, okay? So see you in the next video. Right, so there you have it. Quick time revision. Like and subscribe, and I'll see you next time.